All right, so it's just a minute over 2 o'clock and I've got a lot to cover, so we might kick off if that's okay. So welcome everyone. So today's webinar is on the future or inside the future of construction technology for owners, which is a space that we operate in at Mastt, a space I used to work in when I was in the industry. And so for those who don't know me, my name is Vincent. I'm one of the co-founders of Mastt, and we're a construction technology business. And I'm also the managing director. Now, just before we do begin, so everyone is muted, although you can throw some comments down in the chat if you like. Now, what I'll do, I'm going to stop my video for now, just while we're going through the presentation. But if you do have a question, please just use the chat box, raise your hand and let me know. And there'll certainly be time for questions at the end. And then I'll share the slides with anyone who wants to receive them. My email will be provided at the end. So really looking forward to your feedback. So why are we doing what we do here at Mastt? And to be quite blunt, it's because the construction industry is underperforming. This is the world's oldest, largest industry. And yet over the last 20 years, our productivity has only increased on an average of 1% compared to the world economy at 2.8%. And then manufacturing, our peers in manufacturing are all the way up at 3.8%. So it's really a bit perplexing as to why we haven't been able to achieve the productivity growth of other industries. And then one metric we can look to is IT spend, where we spend only a meager 1.5% of GDP of costs on IT, whereas the banking industry spends 7.2%. But the trend is slowly reversing. It is slowly starting to turn around, but it is something that we do need to accelerate. With urbanisation, we're essentially going through the largest wave of urban growth in human history. And over the next 60 odd years, we're going to be adding 230 billion square meters of new floor space by 2060, so over the next 40 years. So to put that into perspective, that's the equivalent of a New York City every month for the next 40 years. So that's a lot of building happening, particularly in major cities. But fortunately, here in Australia, we're actually leading the way. Lee Jasper from Aconex has called Australia the Silicon Valley of construction technology. And there is a reason for that. We have less people and we're an island. And so it's a lot harder for us to get material internationally. We don't have the resources to be able to throw bodies at the problem. So we absolutely must innovate. And we've been doing a great job of that. We've developed sophisticated global supply chains. Some of the best construction software in the world has come out of Australia. And we're using a lot more these site mobility applications. We've become leaders in BIM. And then when we look to the US, which Rob Philpott has said is around 10 years behind, believe it or not, they're actually still mailing each other checks on some projects in the mail, which is just insane. I don't know why they do that, but that is happening. And I thought differently in the beginning, that the US was surely ahead, but no, they're actually quite a way behind. And there's a lot of great startups, new businesses popping out of this. Some of those companies on the right, Matrack, PayApps, these are all great companies doing great things. Unfortunately, the money is starting to flow to enable this. So capital investment into construction tech has far outpaced the overall venture capital space since 2009. So venture capital without construction tech, the black line down the bottom, versus construction tech in venture capital, and you can see the big uptick there. So it's starting to get really frothy. It's definitely a very under-digitised world, and investors are starting to notice that. So at Mastt, we were fortunate enough recently to receive investment from Australia's absolute A-team for a construction tech business like this. So we received millions of dollars in funding from some of the best venture capital firms, Artesian, the largest VC firm in Asia Pacific, Investable, who's Australia's leading seed investment group, Significant Capital Ventures, who are backed by the Hindmarsh family, and of course, Rob Philpott and Lee Jasper, the founders of Aconex, have also joined our business in addition to Bob Hennessy, who's a former executive CIO of Lend-Lease, Chief Operating Officer of Westpac. So we were really fortunate to be able to select these individuals to join our business and continue our mission of digitizing the construction industry. And then underpinning all of this is Microsoft support. And even right now, I'm sitting in Microsoft's office in Sydney where they host us. So we get a huge amount of support from Microsoft and these investors that are enabling our mission. So our role in this space is really all around the owner. So we live in projects, programs, and portfolios right up to the owner. That's the space we play in, and it's very much a who holds the gold scenario. We can make and transform those biggest impact decisions the owner makes to enable more money to flow into the economy with an application like Mastt. So that's where we play, and how we make the best software for owners is by rethinking these portfolios from the bottom up. So there's three elements, key elements to what we do at Mastt that make our software the best. And that is engineering. We've got some of the best software engineers, including just more traditional engineers who have worked on Elon Musk's Hyperloop and built some of the best software for Yahoo, GitLab, and other major providers, combined with design. So design is important. I mean, we're not building an old SAP system or an old 1990s software. We're building something that's extremely user-friendly, has user experience built in, and looks good and people want to use. And then we are totally obsessive, or well, I am anyway, over customer engagement. And we really bring them along from the journey. And with those three elements, that's our recipe for success in building some of the best software in the construction space. And we do draw inspiration while we're doing this from other sectors. And this will lead into our plan here at Mastt that I'll get to. But let's look at the automotive industry for a minute and some of the innovations that in under 100 years that they've been doing. So they've made vastly superior, better products to what we have in construction. And their top 10 high impact areas are right from autonomous vehicles, connectivity, right down to IoT, 4%, and then 3D printing, 4% as well. So in construction, none of these at the moment really, other than IoT, is featuring in the work that we do. But there is three key ones to take out of this, in my opinion anyway. So connectivity, being able to have everything connected to the internet, enabling real-time maps, real-time traffic, real-time satellite imagery, and being able to then search that network, which brings us into this V2X network, which they call in the automotive industry, vehicle to everything. So when you are connected to the internet, you're connected to the car around the corner, and you know what that other car around the corner is seeing. So you can literally see around corners and coordinate in a mesh grid, mesh network type arrangement. And then I love this concept of, any user input is error. It's actually better to predict rather than to ask the user what they want to do. So these days in a Tesla, if 4 days out of 5, when 4 days out of 5 during the week, this car's picking you up, it'll just take you to work without you even saying anything. So you just get in on Monday, it takes you to work, you don't have to do anything. Any input is error. And so these guys have gotten so good at understanding what people want that they can then just predict and know exactly where they want to go. And this is happening now. People are doing this right now. And most of this is achieved with a bunch of sensors, quite simply, and some learning engines. So I like to just throw this little video down here to explain what exactly that is. And I like to use this example of Homer Simpson. So let's pretend we've got two computers, and they call this a generative adversarial network. And I'll explain to you how it operates. We've got two computers, one's the learner, and then one holds the answer. So we give the learner random pixels on a page, totally random, and we give the answer Homer Simpson's face. And then what the learner does is every second, millions of times a second, it re-randomizes the pixels, sends it to the answer, and says, does this look like Homer Simpson face? Any closer? And then the answer machine says no or yes, and then that goes on, millions of times a second, back and forth, checking if these random pixels look like Homer Simpson. And so this is what it does. So it'll start from scratch in a second, but you'll see that from a random pixels here, it slowly starts to get better and better and better at predicting how Homer Simpson face should look. And this does this millions of times a second to the point where it can predict and replicate exactly what a Homer Simpson's face is. And so this has gotten really good, this technology. So in 2014, they used to be able to produce a random kind of face, didn't really look like a face. 2015 got a bit better. And then in 2017, you can see, I think that's Ryan Seacrest there. It looks almost exactly like a photo. But these days it's so good, they have it on video, and that's how they do a lot of the deep fakes that we see in the news, where it's just indistinguishable from a real human. So this tech is here, it's now, and we can use it to our advantage. And then in the manufacturing industry, where productivity literally has doubled over the last 20 years, leaving us totally in the dust, major sad face, construction all the way down the bottom here below fishing. So what can we learn from manufacturing? Well, robots. I'm sure we've all seen those great shots of a manufacturing plant building cars that can do these repetitive tasks all the time, and it doesn't require any human interaction. And then standardization. So standardization allows us to sustain these big improvements in the efficiency supply chains. So with these two takeaways, the takeaways from automotive, these have really shaped our master plan at Mastt. So what we've done in the last 18 months is quite simply get projects off spreadsheets, which we've done, automate reporting, aggregate data into programs, aggregate data into portfolios, and now we're incorporating risks and integrating that with our current system. And it would have been nice to have done some more challenging things first, but we had to fix these problems. So the plan forward and the future of construction technology for owners is these self-service platforms, time series infrastructure for predictive insights, digital contracts prototypes, which I'll talk about in a minute, and then integrating all of this with on-site data to enable eventually overnight payments. And I'll show you how this happens loosely now through these 4 innovations that we feel will really take construction out of the Stone Age. So the first one is IoT, real-time data. People talk about IoT, a bit of a buzzword, but I'll explain in detail why and how that works here. Second one is automated progress measurement. The third is project predictability. And then the fourth is real-time payments. So let's take a look at IoT, Internet of Things, and how that enables real-time data. And I've got some buddies up here. These are 2 Australian tech companies, Wynomi and Mattrack, who I know really, really well. They use QR codes, which is what you can see on the right, and these Bluetooth low energy beacons, which they can attach to a worker's helmet. They can throw it into a concrete precast panel. They can attach it to a window, and it can track movement, vertically, horizontal, heat signatures, etc. And so what happens is these QR codes, these Bluetooth beacons get attached to material coming from China or wherever it comes from. And you can then see in real time how the building is being constructed. So as they're craning these panels into position, screwing them down, you can actually see the building come to life in a digital model. And so this is happening now. Really, really advanced materials tracking on building sites, tracking things like facade panels, material, shipments, steel, all sorts of great stuff. And this is all coming out of Australia. Innovation 2, automated progress measurement, one of my personal favorites. So there's this company in the US called HoloBuilder. Unfortunately, we don't have any Aussie ones that I could have shared. But they developed this really neat little camera that used to be a human walking around the site taking these photos. And he would have on his iPad a plan, and he would walk to the same positions on this plan, and he would take these photos, and that's how it would automatically track the progress. And they got really good at this to the point where they can use computer vision over the images to understand exactly what they're looking at. So the image on the right is what the photo shows you, and then the model on the left is identifying what these materials are, their position in the building, whether they've been installed over the last 24 hours or not. So these guys have gotten really, really good at measuring and visualizing what's actually happening on construction sites through imagery. But it's kind of cool walking around with that thing in your hand, but why not? Let's just throw it on a robot, and then let's just walk this robot around the site and get to take the photos for us. And so that's what a lot of people have been doing. And this might be more common nowadays with that great TV show Black Mirror that featured these dogs rather than a camera, they had a gun. But this is actually a prototype of that Boston Dynamics robot walking around the construction site, taking the photos. Now, I don't know why they used a dog, but there's this other company in the US that does it with this tiny little robot. It's like the size of a shoebox, but I'm also not convinced that's a good idea because some tradie might just kick it off the edge of the scaffold. But nevertheless, this little tank thing is rolling around trying to do the same thing. But I always thought it would be a drone, mini drone that can come out, fly around the site, fly into ducts, fly around anywhere without interrupting anyone and take photos. So I think the Boston Dynamics dog is, a bit of marketing, but seems to be doing partially the job. But eventually it will definitely be a drone and probably not that little tank thing. And so when we connect these two together, we've got the beacons tracking materials, QR codes, measuring things that are arriving on site. And we've got the dog, or in my preference, the drone, flying around every night, measuring progress. We can then get a view here from materials tracking and measuring progress actually on the job, and then feed that into Mastt or a future version of our system. And that leads me to predictability. So I'll tie this all together in a second, but when we start to generate these warehouses of data around materials tracking, progress on site, payment data, we can then start to use that data to predict the future. So you need two things to cook this cake. You need time series data, roughly 2 years worth, and then you need DOM. DOM is our data scientist, machine learning expert here at Mastt. You can try to find them out in the wild somewhere, but what they do is they apply machine learning and AI techniques through the data to generate these predictive insights. And so fortunately, capital projects offer billions of data points, but at the moment it's all trapped in spreadsheets, and we're starting to unlock that data with Mastt, with our current system, to improve the delivery of projects, spot these risks before they occur. And the more data we get over time, better the outcome will be. So what DOM does is he takes all these different data sets, produces these different clusters of information, which don't mean that much in a static sense, but over time you start to generate a view of how those different data points, different patterns create these swim lanes and measures of project success. And so version 1 of this is benchmarking. Version 2 is what we call an anomaly detector. So we're doing this at the moment across risk, cash flow, benchmarking. And what the anomaly detector does is when you have enough data and you have enough DOMs, you can then use that information to generate an idea or new metrics, new ideas around metrics for what a successful project looks like. And so if we tell this that we have 80 projects that are successful, these 20 were unsuccessful, the machine learning algorithms go through the data and identify these patterns of project success that we as humans can't otherwise comprehend. Relationships between the weather and user activity and other metrics that gives us new benchmarks to then spot anomalies in the data. And so these run live in the background on projects, and they are the equivalent of your banking fraud detection systems, so that in the future, I'm just laughing at a comment, sorry, from the panelists, can't get any other DOMs, there's only one DOM. So that in the future, just like you have a credit card and you get a call before it gets hacked, you have these anomaly detectors running, and they're preventing errors, issues, or risks popping up on your project. Cool. All right, let's move on. Innovation 4. And I'm mindful we've got 10 minutes left, so we'll try to race through this. But really, this is where it all ties together. So one of the biggest problems in construction that really just grinds my gears is that it just takes so long for people to get paid. Like by the time the owner pays money to the builder, and then the person at the very bottom of that project is trying to put food on the table for their family, often the time between when they've installed that thing on site through to when they've actually received the money can be 60, 90 days, which is just crazy. I mean, what industry on earth would you do work and then not expect to get paid for it sooner than that? It's just totally mad. And so part of our master plan is to incorporate these digital contracts. So we have a digital contract prototype. It's a huge step in the right direction because these contracts are currently in basically hard copy documents on people's desks. And we transform those from a physical contract into a digital contract, literally in code. And then once we have it in a digital format, we can then start to integrate with things that are happening on site. So how does that work? I'll step you through it. This is quite complicated, but imagine we take the hard copy physical contract, which is literally written on paper, and then we, through different data extraction methods, we create a digital version of that contract. And eventually, the Standards Australia and these other contract owners don't get their act together. We at Mastt, we're just going to develop our own contract in a digital format. Once we have the digital format contract, we can then interact with those clauses, interact with those rules that are within that contract so that we can then have a view of exactly what the projects, exactly what the contract superintendents, what the contract parties are doing, because the contract is actually the governance around every action, every task that they need to do must go through the contract. And so while this is happening, integrating with our current system, notifications, interacting with the system, we're then taking across to the side the learning engine from the Homer Simpson example. So we're taking all this data, different metrics coming in, and then we're receiving also these environmental inputs from the materials tracking, from the Boston Dynamics dog or the drone that's flying around the site, measuring progress. We're receiving that into our system through the contract. And then as all of this is happening, we're developing these best practice models. We're training the Homer Simpson face per se to develop a view of the future automatically as we start to create enough data to be able to predict the future. And so we call this Mastt Cognition Services, and you can think of it as like a robot running alongside the project. So how does actually this enable real-time payments? It's kind of a little bit about how it looks. So how does this enable real-time payments? Well, with the actual infrastructure that governs payments and governs, the things that we must do, insurances, tick these boxes, tick those boxes, etc. Now in a digital environment, we can bypass these major blockages that are administration of contracts, literally having to pick up and read and understand the contracts, and we can just use our system to make these payments automatically. And this will this will make the largest issue in the construction industry, which is the major cause of disputes globally, entirely go away. So the number one cause of disputes globally, believe it or not, is a failure to actually understand the contract. That's the number one cause. Then the number two cause is to failure to actually administer the contract because they're too busy out doing the job site, working on the job site, rather than reading the contract document and then sending a letter to someone. So no wonder these disputes happen. It's just mad. So with that gone and infrastructure in place, we can enable real-time payments in the construction industry. So here's how it works. So have the owner, could be the government, another entity, large asset owner, and they've got a project bank account with money in it. That's what they have now. They're going to appoint a superintendent to manage that project, and they're going to use a digital contract to do that. We're going to throw the hard copy out the door. We're also going to engage the builder with a digital contract. And that builder is going to engage the subbies with digital contracts as well, because who wants to use a hard copy when you have a digital contract? So these subbies are doing the work on the site. We're integrating the site with our IoT sensors, receiving material, tracking material as it comes to site. Our mate, the dog, is walking around the construction site every night, maybe every morning, whichever, and he's measuring progress visually through computer vision, and then we can actually reference that back to a BIM model. That's one way to do it, but there are others. And so this information is coming in automatically integrated with the site without any human interaction. Progress is being measured, materials are being tracked, and then that is flowing up through digital contracts that are checking the rules, checking the clauses, checking the compliance, checking the governance automatically to then enable a payment. So at the end of the dog's walk every night, the owner will do a trickle payment, out of their bank account down into the bank accounts of the subcontractors overnight. So you're a subby, you go to work, you do work that day, you wake up the next morning, you've been paid for the work you did that day. There's a lot of things that definitely work out, but this is conceptually how it will happen. And there are people very, very interested in making this happen. And so what we're doing at Mastt, we're doing this part next year, then we're going to do this part, incorporating the subbies the year after. And so then how do you actually view this in our system? So you've got all of these payments every night, data is just pumping through, progress is being made, dogs are doing walks around the site, we're paying people, and then you can visualize this in the system. So using Mastt, you can log in, you can see the progress, you can see the progress claim that's been paid automatically, and you can click on it and you can actually see a video of the progress that you've paid against that exact progress claim, all tracked and all stored in our system. And then alongside that, we're running the learning engine and the prediction engine, and we're taking all these metrics, using our anomaly detectors, using our DOM to predict the future of all these contracts and know exactly the problems that are going to happen, the breakdowns that are going to happen before they occur. And that's not data that we hold. We feed that back in to the industry. So the subbies get this data, suppliers get this data, and the builders get this data. Everyone's protected. No one's ever going to lose a dispute or end up in court. The contracts are here to protect everyone and make sure that all of the parties get paid on time and in a more timely manner. And then with the transparency, I mean, the benefits of that, having everything transparent, keeps everyone on the same page. And so this will happen probably in the next 4 to 5 years. And so in our model of the owners where we play, we're really just now going downstream to bring even more real-time information through digital contracts up to the owner. So how will the market evolve around these innovations? So the minority will continue to use spreadsheets. Some people love spreadsheets. That's all good. They can keep trying. But there is a lot, eventually, these people will be reprimanded. Like it just seems to be, it's just not good enough anymore to be managing a project or doing some of these really important things with a spreadsheet when there are alternatives, better alternatives, safer alternatives to using a spreadsheet. The majority will shift into easy to use software, start to take advantage of these integrated project controls and start to benefit from live data. The innovators, which do exist in Australia, and there's loads of them, are identifying early tech partners to be a part of these development journeys. And that is an agile development journey. So we don't have all the answers. It is an agile process, not a waterfall process, but we learn, we iterate, and we grow as we go through discovering this process. Cool. How can you get access to this stuff? So there's loads of great places to get information on these things. So the first one is you need to plan to get away from these problems. Once you've done that, you can then look to engage. So there's heaps of awesome companies popping up in the construction tech scene, the prop tech scene. Universities like Western Sydney University have got a full construction incubator unit that can be partnered with. And then of course, there's a bunch of startups, launch pads and accelerators in the industry that are churning out some really great stuff. There's a bunch of places you can go to join and receive information, attend webinars such as this, read blogs from influencers, and just get that kind of thought leading, cutting edge thought leading from other industry partners. And then you can experiment. So you can actually experiment with your own machine learning algorithms using Google's TensorFlow. It operates like a spreadsheet. And if you put enough data into it, just like in a spreadsheet, you can then use that to predict your own outcomes and do some machine learning discovery. So these things are available right now for people to try. And I'd encourage everyone to have a bit of a play because it is kind of fun. And I'd just like to kind of close with just reminding my guests of these webinars that it really does all start with the owner. And so the owners are the ones who can put in place the most change, affect the most transformation in the industry, because it is a very much who holds the gold scenario, and the owners can implement the power downstream to really take all of this stuff and accelerate this big change into the future. So that closes our webinar for today, nearly bang on 2:30. So I try to keep it short, try to keep it sharp. And I appreciate everyone joining and everyone listening in. And I've taken note of a couple of questions here from different individuals in the chat that I'd like to take some time, now since we're out of time anyway, to take some time offline to discuss these questions with you guys. And I've got heaps of thoughts, Jeremy, on those questions that you just asked here. So I'll reach out separately. But thanks a lot, everyone. Hopefully that was informative. Let's turn my camera back on. Yeah, thanks a lot, everyone. Hopefully that was informative, and I look forward to following up and engaging with you all on this journey. But thanks for your time, everyone. Really appreciate it, and I'll talk to you soon.